this is Derek again. I'm in my little office today. I've got a little office that I do some work in when I don't want to be in the shed, so that I won't be clean and things like that. So what I want to do today is a follow-up on the bike project that I did. I did say, if anybody watched it or not, that I would be doing some videos on electrics. Now these electrics is going to be for old motorcycles, not modern stuff, no computers or anything like that. This is all perhaps 1940s, 1950s, 1960s motorcycles, wiring up lights, because I think if there's anything that people get confused about, it's wiring up these old bikes. I get a lot of people on the internet asking questions, and it is confusing, and it's confusing even to auto electricians, experienced people, because modern stuff is not wired like old wiring, basically because they mix AC and DC circuits, and they don't do that now. It's all DC, it's all rectified, and it's DC. And they didn't have the technology back in the day, so what they had to do was make do what they had. So it's difficult to know where to start. I'm going to start where I think is at the very, very, very beginning. So if you're bored with this and you want to skip, I'll be doing a few videos because I can't do it all in one hit. It's far too much. So I'm starting off with the very basics, and if anybody wants to skip a few videos and skip on to something they're more interested in, then do what you like. I'm not really bothered. So I'm going to start off at the very beginning on basic electrics. Bear in mind, this is motorcycle electrics, not house wiring, not computers or anything like that. This is all old school 6 and 12 volts DC electrics. So if we make a start, I've got to start somewhere. I don't know whether to start with the tools you need, or testing, or wires, or whatever. I'm going to start with what basically electricity is, and the difference between AC and DC, which I think is important on the old bikes. You've got to know what's AC and what's DC. So let's make a start. AC means alternating current. So alternating current is what you would normally see coming out of a light socket, something like, let's have a look. That's AC. All your house wiring is all AC. DC is a battery. Okay, so AC is alternating current, and you would normally associate that with your house wiring, and DC is a battery. Now, having said you get this is your house wiring, you also get this on old bikes as well. You get it on modern bikes, but you never see it because it's changed way before it becomes before you ever get into it. So alternating current, the way you can tell anything's alternating current is if you've seen a symbol and it's a symbol like that, that means it's alternating current. If you see direct current, it's a positive and negative. Basically, alternating current doesn't go from one side to the other, it alternates back and forward. So you can see AC, if this is your current, this is your electricity, that's one end of your wire, that's the other end of your wire, the current is going back and forwards. DC goes from one to the other. Now they're not actually sure which way it goes. They used to think it went from positive to negative, now they think it goes from negative to positive. It doesn't matter. All you need to know is this: if it's DC, it goes one direction and flows in the same direction. So let's say it's negative to positive, so the current goes in that direction only. So it goes negative to positive and it flows in that direction. Alternating current doesn't flow, it goes back and forwards. That's the only difference with electricity. The electric is the same, you get the same effects of it. Some things, some components are what they call polarity sensitive. It has to be, they have to be wired negative earth or positive feed or whatever. And some things will only work on AC and some things will only work on DC. But the actual electricity is the same effect, everything's the same. Okay? So, we know that alternating current direct is DC is a battery. So DC is a battery. So AC current you get from the house wiring or whatever, it comes down at the socket in your home, but you also get AC current from a magneto. And DC current comes from a dynamo. They're very, very similar components. They are both generators. They both generate electricity. But an AC current, a current from an AC magneto produces AC, and DC current from a dynamo produces DC. That's the difference. And it's the way they're fundamentally wired, and there's nothing you can do about it. It either is a magneto or a dynamo. I can't go into how they're wired and what the difference is. It's far too complicated at this stage, and you don't need to know anyway. Right. So what is the fundamental difference between AC and DC? AC current cannot be stored. You cannot store it because it's a coil with a magnet rotating round it. So as soon as you kick your engine over and that magnet starts to rotate around the coil, it generates electricity, it generates AC. Right? As soon as that engine stops, the current's gone. You cannot store AC. So as soon as your engine stops, your generator stops, your supply is gone. DC, you can store it in a battery, and that's why you have a battery, because you need, if you have a starter motor on, I mean, I'm not talking about starter motors back in the 60s, but you need, if you wanted a parking light on or anything like that, you need something that's you got a power supply when the engine stopped, and the only way you can do that is to have a battery, and battery is DC. So what do? You have to generate your electricity, so when you want to store it, so what you have to do, you have to convert the AC to DC. So the electricity supply that's being generated by the magneto is no good to you most of the time. Well, it is, but it's not really convenient. So what you do is convert it to direct current, and you convert AC to DC by a rectifier. And this is where people start to get confused. What's a rectifier? What's a regulator? What does a rectifier do? That's what a rectifier does. It converts AC to DC. So basically you've got the modern rectifiers like this, but it doesn't matter, the old rectifiers are the same. You put your AC onto there, so you've got one wire coming from that side, you've got one wire coming from that side onto your rectifier, and then it comes out as positive at that end and negative at that end. So you've now, this is going back and forwards, this is going that way and that way, and this is going that way and that way. But when it comes out of here, it's going that way, because the same way it becomes DC, becomes direct current, and then you can charge the battery, because you can't charge the battery with AC, it needs DC. So that's why you have a rectifier, and that's it. There's nothing mysterious about a rectifier. It's no, it's not, it's not wizardry or anything like that. It basically just converts AC to DC so you can charge your battery. So we know what a battery is, and we know what AC is, and we know what a magneto is. Basically. Right. So we need to. This is where I didn't know where to start. Where do you start with this, or do you start with that, or do you start with tools? You've got to start somewhere, right? So volts. So this is a 6-volt battery. So that is a 6-volt battery, 6 volts. Okay. So your motorbike is normally either 6 volts or it's 12 volts. So the voltage is the electrical pressure. That is the pressure coming out of that battery. Now that is a 6-volt battery off my little motorbike in there. That could be this size. If it's 6 volts, it's 6 volts. No more pressure coming out, it's 6 volts. If it's 12 volts, it doesn't matter if it's that big, this big, that big, or this big. It's still 12 volts. So it's either 6 volts or it's 12 volts. DC. So you've got 6-volt batteries, you've got 12-volt batteries. So if volts is the electrical pressure, that's the force that's coming out, what's the amps? This is again, this is what people get confused on, is volts, amps and watts. And there's resistance as well, but come to resistance in a little bit further on. So volts is the pressure, volts is the force, amps is the amount of electrical energy that's available, the volume of it. So let's pretend that this battery was a hose pipe. So out to this positive side, negative side goes down to earth. So positive side is where your supply is coming out of, because it's going from there to there. So it's going in the same direction all the time. So the supply is coming out of here, and it's coming out at a force. Now let's pretend, instead of that being a wire, let's pretend that was a hose pipe, water coming out of a little pipe. So if that was a little tiny pipe, say a millimetre diameter inside, you get water coming out like a jet of water coming out. Okay, that's your pressure. And you'd have a certain amount of force to that. There'd be a certain amount of volume. But if you imagine if that pipe is now as big as a fire hose, imagine it was this diameter, and you've got the same pressure but that much more of it, the force would be tremendous. So you have a little tiny hose pipe or a whacking great big one, that's the amps. So if you've got